Algebra 2, here we are with the Unit 3 Summative Review. We're going to get us started with 3a, with the absolute value. Okay, remember inside is opposite, so minus 2 actually moves it 2 to the right. Outside is the same, we're going to go up 3. So we're 1, 2 to the right, up, 1, 2, 3. Okay, now absolute value should make a V. We don't have any multiplier in the front, so it's like a 1. So we're going up 1, over 1, both ways. Kind of tough right there, and the lines are kind of faded. Okay, make your absolute value V. Domain for all of these should be all real numbers, because we go forever to the right and forever to the left. And our range, this one's going up, but it's not going down forever. It hits its lowest point right here at 3. All of our y's are greater than or equal to 3. So your domain is going to be all real numbers, and then your range should be related to the y coordinate of your corner or vertex. And it would not hurt us to write that down. Next one. Almost a flip-flop opposite of what we just had. Plus 3 is going to go 3 left. And minus 2 is going to go 2 down. So 3 left and 2 down. We're going to be at negative 3, negative 2. And last time we went up 1, over 1. This time we do have a multiplier of a half. That's going to be like our slope. Up 1, out 2, up 1, out 2, both ways. And draw your lines. All real numbers. Maybe you want to use the fancy R this time. And your range is going to be greater than, we're going up again, or equal to negative 2. Last one for absolute value. Okay, this time we have an inequality, so we're going to go 1 left, 6 up. So we're going to be at negative 1, 1, 2, 3, 4, 5, 6. And we have a negative 2 multiplier. So that's down 2 over 1, down 2 over 1. We'll go that both ways. Greater than, that's a dotted line. And where are we going to shade? Okay, just put your pen or pencil on one of the dots. Which way has y's that are greater than where that currently is? Up. Shading the top side. And for inequalities of shading, we do not have to do domain and range. All right, pretty solid there for absolute value. Quadratics, x-squared graphs, parabolas. Okay, gets a little bit more complicated just because you have specific things we need to remember and know for each one. Okay, so this is vertex form. So we need to know the vertex, the axis of symmetry, and our y-intercept. So it's in vertex form, so hopefully we can get that vertex rather quickly. Remember, it's opposite, comma, same, just like we had for absolute value. We'll have negative 3, positive 5. Opposite, negative 3, same, positive 5. Okay, your axis of symmetry should match our x-coordinate, negative 3. So draw that axis of symmetry down the middle. Okay, your y-intercept we could get by plugging in 0. Your y-intercept should always be 0 comma something. We can plug 0 in, or we can do our points pattern and see if we hit it on our own. Okay, so step 1, go over 1. Normally over 1 squared would mean up 1. We have a negative 2 multiplier. We're going to go over 1, down 2. And reflect it over. Next one, go over 2. 2 squared is 4. Normally you'd go up 4. We have a negative 2 multiplier. So instead of going up 4, we're going to go down twice as much, down 8. And reflect it over. Okay, there's our 5 points. We still have not hit the y-intercept though, and I think it's going to be off the graph. Let's plug 0 in. 0 plus 3 is 3. 3 squared is 9. 9 times negative 2 would be negative 18, and then plus 5 is negative 13. So that is off the graph. We can kind of do our best here. This is negative 10, 11, 12, 13. Try to do the best you can. Okay, and I'll do the best I can to make sure that these fit on the graph for the test. But you might have an oh no moment, and you're going to have to do the best you can. Okay, same thing as last time. Our domain is all real numbers. This gets pretty steep, but it does keep sliding left and right forever and ever. Range, again, it's going to be related to your y-coordinate of the vertex. So 5, we're going down, so all my y's are less than or equal to 5. All right, so that was vertex form. Number 2, I guess number 5 on the paper. Standard form. Okay, include all key features. Lucky for us, the key feature list is exactly the same. Vertex, axis of symmetry, and y-intercept. Okay, it almost goes in reverse, though, of ease to do. Remember, our y-intercept is always 0 comma. 0 comma is really easy to do in this form because 0 squared is 0. Something times 0 is 0. So it's going to be a last number at the end, negative 3. Okay, getting your vertex is going to be a little bit trickier because there's a formula to use. X equals negative b over 2a. That's a terrible 2. Okay, our b value is 2, so we're going to do negative 2 over 2 times 1. Our a value is 1, 1x squared. So our x number is negative 1. Okay, axis of symmetry should match your x-coordinate. To get your y-coordinate, we're going to plug that negative 1 in. So we have negative 1 squared plus 2 times negative 1 minus 3. Very easy mistake to make right here in the beginning. Negative 1 squared. Negative 1 times negative 1 should be positive 1. Then we have a minus 2 and a minus 3. Our y should be negative 4. Negative 1, negative 1, 2, 3, 4. There's our vertex. Axis of symmetry should be negative 1. We already have our y-intercept on there. If you don't already have it, put it on there and reflect it over. And we can get another set of points for good measure. There's no multiplier, so it shouldn't be too bad. If I go out 2, 2 squared is 4. Up 1, 2, 3, 4. And there it is. Domain, all real numbers. Range, my y is greater than or equal to -4. Okay. Backside, factored form. This one looks a little bit different, and it's going to have something a little bit different. Zeros is what we want from this one first, and then we still have our vertex and axis of symmetry. So vertex and axis of symmetry are on all of them. Y-intercept is on the first 2, and then zeros is on the last one. Okay, zeros are what makes the whole equation equal 0. So if I have something times something else equals 0, one of the two somethings has to be 0. What makes this first one equal 0? If x was 2, and then we would have 2, 0. What makes our second group equal 0? If x was -3, and then we'd have -3, 0. Okay, now our parabolas are symmetric, meaning that these two would reflect over onto each other. So what is our reflection line that should be right in the middle of those 2 points? Middle of 2 points, midpoint. Think back to geometry. You're going to add your 2 x numbers together and divide by 2. -1/2 is your x number. And that is also your axis of symmetry. Okay, so -1/2. Not fantastic, but whatever, we can live with it. Okay, now this is a no calculator test, or no graphing calculator test, because it's a graphing test. So you're going to need a scientific calculator. This would be the one spot so far I think that you'd maybe need it. Okay, negative, parentheses, -1/2, -2, close parentheses, times, open parentheses, -0.5, plus 3, close parentheses. We're plugging in our x to see what our y would be, 6.25. So 1, 2, 3, 4, 5, 6, and a little bit more, 6.25. Not a perfect point, so let's label it. Okay, technically, that's all you need, your vertex and your zeros. Okay, if you wanted another set of points, pick a nice point close to -1/2. I don't know, 0. 0 minus 2 is -2. 0 plus 3 is 3. -2 times 3 is -6. Negative sign waiting for you in the front flips it back to +6. So basically I just put 0 in. I got 0, 6, a nice point. Reflect it over, you'll get -1, 6. If you wanted more points. Okay? All real numbers, and y is less than or equal to 6.25. Last one. Inequalities, and we're back to vertex form. Okay, so my vertex is -4, -6, opposite, same. My AOS, axis of symmetry, is x equals same x number okay, and y-intercept. And again, this is not going to be a friendly y-intercept, but it is 0, something, right? So, 0 plus 4 is 4. 4 squared is 16, and now we have divide by 3, or times by a third. 5.3 repeating, minus 6, we got negative 2/3. Okay, you're in Algebra 2. Don't round this, don't cut it off. It's negative 2/3. 0, negative 2/3. Not a pretty point. Let's write it down. And also, we already have it, so let's reflect it over. 1, 2, 3, 4 to get to the line. 1, 2, 3, 4 to get past the line. Okay, we have a 1/3 multiplier. So what number works from our points pattern with 1/3? Out 3. Because 1, 2, 3 out. 3 squared would be 9. And then 9 times a third would drop us down to 3. 1, 2, 3 up instead of 9 up. Reflect it over. And that should be enough. Greater than. Dotted line. And shade on top. Alright, folks, there it is. Hopefully you found that helpful. Okay, you have the other half to do on your own, and that should prepare you for the test. Good luck.